Hello.
Good morning, sir.
Hi, Siddharth. Good morning. Hi, Kirtana. Good morning.
Good morning, sir.
Yes, Kirtana. I think yesterday you are not there in the meeting, correct?
Yeah, the network connection was not there because I was out.
Okay, no issues. I will send you the recordings. Please go through the recording.
Okay. Okay.
Okay, Siddharth. Do you have any doubts from yesterday's session?
Sir, yesterday I couldn't rewatch our recording, sir. So after today's class, uh, I will see both the videos, sir, today's and yesterday's. After that, I will ask, sir.
Okay, I have to send you the recordings. I have not sent you the recordings of yesterday. I have sent you the recordings of last week. Sorry,
Uh,
Tuesday recording.
okay.
Please go through both the recordings and do ask me questions.
Yes, sir.
Okay, so let me share my screen first. Okay, so can you see my screen?
Yes, sir.
Yes.
Okay, so this is where we started yesterday, correct? So a small recap. So I told you, or we learned what is machine learning. Okay, so machine learning is nothing but an art of teaching the computers to learn patterns from the data. Okay, so once the machine learns from the data, okay, so it is going to perform some task. Okay, that means it is going to give you some kind of predictions, or it is going to classify things for you. Ultimately, you have some insights. So all these things, whatever you are doing, okay, that means you are making a machine to learn patterns. When you are doing all these things, you're not explicitly programming the machine or the system. That means you're not writing syntaxes. You're not saying that if mark is greater than 40, pass. If the marks is less than 30, marks is greater than 40, pass. Less than 40, fail. That's not what you're saying. Instead of that, you're providing the machine with some kind of data. Okay. So when I say data, you have the student's marks and all the student marks, whatever you have, okay, that is being fed to the machine and the machine figures out the pattern by itself. Okay. So it will figure out by itself that if the marks are less than 40, then the student has failed in the examination. If the total marks, sorry, not the total marks, if the marks is marks of a particular subject, okay, marks obtained in a particular subject is greater than 40, okay, that means the student has passed in the examination. This pattern, the machine learns by itself. We don't have to explicitly program, and that is what is machine learning. So, if you have to speak in a very simplified way, okay, so you define machine learning as instead of writing rules, we just give data and the computer learns the rules. Okay, so that is what machine learning is. So, this machine learning has a cycle. Okay, so it undergoes a series of steps. The machine learning enables the computers to learn from data and make decisions without being explicitly programmed. That is what it is. So now you have the data. Okay, it could be any data. So let's say like here you have the students' marks detail. Okay, so you have the basic information. So this is the information that you need to provide the machine, and the machine has to learn from this data. So that means in this particular data set, what you have is each and every student's marks detail obtained in a particular examination or test, or maybe combination of everything. Okay. So that means if a student has scored 35 in an English subject, 40 in maths, then let's say like 48 in science, 54 in social studies, and let's say like 70 in Hindi or Kannada or Tamil, whatever it is. And you have the status. Okay, status in the sense, what is the result of this particular student in the examination, whether he has passed the examination or failed in the examination. So this is the level of detail you have in the data set that you have. This is what you're providing the machine to. Okay. So now the machine learns about all these things. If the student has scored 35 in English, 40 in mathematics, etc., etc. Okay. Then the student has passed in the examination. Now you give the second row of data, that is second student's data. It learns about the second student's data. Okay, so likewise, if there are 100 students in a class, you input all the 100 students' marks to the machine, and the machine learns about all these things. So while it is learning, it figures out a pattern. Okay, I told you the pattern is, if in a particular subject, the student, if the student is scoring less than 40, then the result will be fail, because even if the student fails in one of the subjects, the result will be fail. Okay, so it learns that pattern. Okay, it compares marks of all the subjects. Okay, it sees if the marks scored in each of the subject is greater than 40. So if that is the case, only then it is going to like input, or it is going to give a result saying that the student has passed in the examination. Okay, that is what it learns. Okay, so it learns from data that is already in existence. Okay, so you want it to learn something, correct? So for example, if you want the machine to learn about cats and dogs, then you'll have to show some images of cats and dogs. Only from examples it can learn. Okay, so the objective here is, when you provide a picture of, like, let's say like you are providing hundreds and hundreds of images of cats and dogs to this particular machine, and the machine is learning about these cats and dogs. Okay, now let's say like you have a different set of images of cats and dogs. Okay, there are variations. For example, in this images that you are showing to the machine, let's say like you are talking about the Indian breeds. Okay, so whatever cats and dogs exist in India, or let's say like we're talking about the breeds in Asia. Now you have some of the images from a different region, North American region, European region, or whatever it is. Okay, so the machine has learned about the dogs and cats that is existing in Asian region. Now similar pattern will exist in the images of cats and dogs from a different region. Okay, cats and dogs, they have similarity, correct? So the characteristics of a cat in India will be almost similar to characteristics of a cat from European region or North American region. There might be slight differences, but majority of the patterns or the characteristics will be same. So first, you will have to make the model learn from some examples. Okay. So when you make the machine learn from examples, it knows how a cat looks like, how a dog looks like. So in future, if you have to give a particular image, and you ask the machine to classify that particular image, it is going to do the job. It is going to answer you whether that particular image is of cat or a dog. Okay, so This is some generic example. Like I will give you a more what to say, like industry example. So let's say like yesterday I spoke about this. Okay, again I'm repeating. So when you go to a mall, correct? So at the mall, or you say like if there are n number of shops in a mall, okay, maybe like you are interested in a clothing brand, okay, so maybe Zudio or whatever it is. I don't know like the names of all these brands, okay. So let's say like you have brand number one, brand number two located in this particular mall, okay. So brand number one is a clothing store. Brand number two is like footwear and accessories. So now you're interested in brand number one, uh, which is a clothing brand. Now, when you enter this particular brand, that is the shop, at the entrance, there might be somebody who's trying to welcome you, or there may not be anybody who's trying to welcome you. Okay, so you may have somebody, you may not have somebody. So if you have somebody at the entrance welcoming you, so that's a good customer experience. You feel good about it. Okay. So, and there is some guidance. Okay. So let's say like at the entrance, there is somebody who's trying to like welcome you, and you check with this particular like security guard or whoever is trying to welcome you, and you ask them like where is this particular brand of clothing available. So that particular like guy or whoever is there at the clothing store, he is going to help you out. Okay. So he is going to direct you to that particular area where your brand of clothing is available. Okay. So there is some direction. You feel good about it. But typically this may happen or may not happen with these brands. Okay. So now here, if a machine comes or if there is an application that welcomes people by itself, okay, there need not be any personnel standing at the entrance of the store and welcome you. Okay, it does not, it is not necessary. Okay, so instead of that, you can place an LED screen. Okay, so you place an LED screen, and in the LED screen, what happens? This there is a device, okay, which captures your photograph, and whatever photograph is captured, that is compared against photograph in the database. Okay, that means you're a frequent customer to this particular store. Okay, let's imagine that way. So if you are a frequent visitor to this particular store, okay, your picture would have been stored in a database because you're a premium customer, and they have all your information stored in the database. Okay, so that means like if they want to check up some of the information, then they go and check your information. If they have to notify you something, they will notify you. Okay, basically whatever information they have, that is going to help them in some way. Okay, either in marketing, promotion, advertisement, whatever it is. So they have your picture. Now whatever picture has been captured, that means the device at the entrance captures your face. Now there is going to be a comparison of your face against what is existing in the database. Then if it finds a match saying that your facial character is matching with somebody in the database, then it is going to welcome you. Okay. So when it welcomes you, it gives a customized message. Okay, saying that, hi, Miss Kirtana, welcome to our store. There is a discount on clothes, or let's say like t-shirt and jeans going on at first floor, second floor. Okay, so now what is this like LED screen that is displaying you, like it is displaying you a customized message where it is greeting you. Okay, when it is greeting you, it says Miss Kirtana. Okay, now how did it identify that you're a female? Okay, so it compared your photograph that it captured against whatever is existing in the database, and it did the classification. Okay, so for doing this classification, like it should have been trained on a lot of images of male and female. So I told you, or I gave you the example of cats and dogs. Similar way, it should have been trained on a lot of examples on male and female. That means the machine now knows how a male looks, how a female looks. So now, based on all the characteristics or all your facial characteristics, it has made out that you are a female. So now, when you're a female, right? So it is trying to greet you saying Miss or Mrs. Again, it knows, okay, how it is saying you're a Miss. Okay, it may know, I don't know, like how it is thought. Based on whatever it has understood, it can identify you as Miss Kirtana. Okay, so it is also giving you a name because in the customer as a database, your details are already stored. Okay, your picture is already stored. It has found a match. So with reference to that it is going to go and search in the database, and it is going to get the customer name. So whatever is the customer name, it is going to greet with that particular name. Okay, so that is what is happening in the industry example. So basically, what I want to tell you, you have some information up front. This information has to be trained, or like the model or the machine has to be trained on this upfront information. Okay, so before training, like you'll have to do some kind of pre-processing. So when I say pre-processing, you have to clean the data. So like when you have this images of male and female or cats and dogs, like there could be duplicate images. Okay, so let's say like you have 10 different images of cats and dogs. So if you see this 10 different images, some of the images look similar. Okay, that means there is a duplicate of one of the image, or like couple of images. So you don't have to teach the machine about a particular cat twice. It's not required. So there is duplicate entry. And like some of the images has like the some of the images are blurry. Okay, so you cannot make out whether that particular image is of a cat or a dog. So if you see, the data set is not proper, it has some inconsistency, it has got some kind of error, which the model will learn if you provide it as is. That should not happen. You should clean this, you should organize this, you should prepare this data before you go and train the model. So this is the second step in machine learning implementation. Step number one, you collect data. Okay, that means if you don't have the images of male and female, then you go to a particular repository or a system from where you can collect this. Let's say like you have all your male and female images in your phone, okay, or in your Google Drive or something. Okay, you go and collect that. So first step is data collection. Then after you collect the data, you pre-process the data. So pre-process means removing all the duplicate entries, and if the image is blurry, you replace that image with something that is of good quality. Okay, you can make out if the image is of cat or dog. So that is step number two. So when you have this, like when you have done this pre-processing, next step is you go and train. So training is where the machine understands if the image is of a female or a male. Okay, let's say like it understands based on whatever images you provided to the model. So now, since it has understood, it has learned about all these male and female images, it can do the prediction on the set of images you have in hand. Okay, the example that I told you, okay, is of like a mall example where the photographs of different people are taken, right? So there is this prediction always happening. Okay, new customers are coming inside the like visiting the mall. So every time their picture is captured, their photograph is like compared against what is existing in the data. So then it needs to do a classification. Okay, that is the task. So when it has understood all these things, it can classify, it can address, or it can greet the customer the right way. Okay, so this is what happens in a machine learning implementation. Okay, or you can say this is the life cycle of a machine learning implementation. So is this clear? Any doubts, Kirtana and Siddharth?
No doubts.
No, sir.
Fine. So application, I told you, email spam detection, product recommendation, voice assistants, etc. This we already spoke. Like I don't have to repeat this. The next one is difference between traditional programming and machine learning. Okay. So when you say traditional programming, okay, traditional programming is nothing but, so in general, programming first. Okay. So what is programming? Programming means writing some instruction, right? Writing some rules. Okay. I told you if you have a data set, if you have all the student details and their marks secured in a particular examination, ultimately you have to tag whether the student has passed or failed in the examination. Okay, so if that is the case, maybe you can write syntaxes, you can write rules and classify if the student has passed or failed in the examination. You can do this, or you can go the machine learning way. Okay, it is up to you like how to proceed. Okay, which is efficient, which is more accurate, all these things you'll have to decide. So let's say like you are doing this programmatical way. Okay, so if you are doing this programmatical way, then you will write instructions, you will write rules saying that if marks is greater than 40, then pass. If the marks scored in a particular subject is less than 40, then fail. So this is what you write. Okay, you write this. Based on this, the machine will act. Okay, it is going to tag each and every student's pass or fail status. In machine learning, we are not doing this. In machine learning, what we are doing, we are giving all the information that is present in your Excel file or CSV file, whatever is there. Now it takes the input, it figures out all these patterns, right? All by itself. And based on whatever it has figured out, it can give you the results on the set of students that you have in hand. Okay, so that is what traditional programming and machine learning is. Okay, so one small example. So Kirtana, I would like you to answer this. Okay, so I think you are not there yesterday, correct? So can you see this traditional system or a traditional robo and an AI powered robo? So can you make out the difference, or can you make out the difference here? What is this traditional robo, and what is this AI powered robo?
Like the traditional system, they have like the instructions built in, like they only answer specific questions, which is like from the data stored in them. But then the AI powered system can understand and they can give other recommendations or suggestions.
Exactly. Okay. Yes. So traditional systems, as I told you, it is instruction driven, whereas whereas AI powered systems are intelligent. Okay, they act intelligently. Now, how traditional system and AI powered system act? Okay, let us see. So, let's say like you're trying to interact with these two robots. Okay, one is instruction driven, one is intelligent. Okay, so let's say like you're talking to this particular robot. Okay, or let's say like Alan is talking to this particular robot. Okay, he says hi to this particular robot. Okay, the robot responds with a hi. Then Alan has a follow up question. He asks, "What is your name?" The robot says, "I'm John." Then again, Alan follows up with a question asking like explain AI in simple terms. Now the robot goes bleak. It does not know how to answer. So this is what is happening with your traditional robot. Now, if you compare this with the AI powered robot, what happened? Okay, again, let's say like Alan is communicating or conversating with this AI powered robot. He says hi first. The robot responds, "Hello, Mr. Alan. How are you doing today?" Okay, then Alan says like, "I'm fine. Thanks for asking." The robot has a follow up question. It asks, how may I help you?" Okay, Alan says, "I have questions for you." Robo says, "Yes, please go ahead." Okay, so can you see the conversation? Can you understand the conversation? Okay, how you're conversating with a traditional robo and how you're conversating with an AI powered robo, and what are the responses of a traditional robo and the responses of AI powered robo are. Okay, so there is a difference, right? So altogether they are robo. Okay, they have to act in a similar way, but like there is some intelligence in the AI powered robo. Okay, it is not based on rules. Okay, so this traditional robo cannot go beyond certain limits. Okay, so it's been programmed this way. If you say hi, it will reply hi. If you ask its name, it will say its name. Beyond this, it cannot go because it has not been instructed that way. Okay, so if you can instruct, let's say like you're asking explain AI in simple terms. If you would have given some definition to this particular robo, saying that this is what you have to answer when somebody asks you like what is AI, then it would answer. So for that, you'll have to write one more instruction. Okay, so here there are two instructions saying that when somebody says you hi, you have to reply with a hi. When somebody asks you what is your name, you'll have to reply with your name, that is John. Except that it cannot do anything. Okay, it's not programmed that way. Now, this AI powered system, okay, it is built intelligently. That means it is not instruction driven. Nobody has written an instruction saying that when somebody says hi to you, you'll have to reply this way. Nobody has instructed that. Okay. So this particular AI powered robot has been trained on different things. Okay. It has been given different scenarios. That means when somebody asks or tells you hi, you'll have to respond this way. Okay. That particular training is there. Okay. That means Alan is saying hi. The robot is saying, "Hello, Mr. Alan, how are you doing today?" So, if this is the reply from the robot, then it has learned that when somebody says hi, you'll have to say hello and you'll have to greet him. Okay, addressing him or her by their name. Okay, and you should also ask them like, "How are you doing today?" Okay, this is what it has learned. And how did it learn? Based on the examples that you gave. Okay, for example, you probably give hundreds and hundreds of conversation. So everybody, okay, when they are interacting with this particular robot, when they say hi, the robot is the reply is hello, Mr. Allen, how are you doing? Okay, so some kind of conversation of this sort has happened already. Okay, so that is what the machine is being fed. Okay, so when there is a conversation, okay, it should be a decent conversation. When somebody says hi, you should greet them with their name. Okay, that's how it has been trained. So it has been trained that way. That is why it is like greeting you this way. Okay, so if you see this, it has learned something and it is doing something based on its learning. Okay, this is intelligence. Okay, so in the other robo, you don't see that intelligence. Okay, that is the difference. Okay, so this is your traditional system and AI powered system. Any doubts?
No, sir.
Siddharth, any doubts?
No, sir.
Okay. So examples, I think we have spoken about this, correct? So movie predictions, movie recommendations, yes. So based on your watch history, what is the genre of movie that you watch? Okay, the machine can understand and it can recommend you movies on the same genre. Okay, so how does the machine recommend you movies here? Okay, so people of your nature, okay, users of your nature have already watched movies, okay, in this genre. Okay, let's say user number one. Okay, user number one is regularly watching romance movies. So let's say like you are user number two. So you are watching movie number one, movie number two. Similarly, user number one also has watched movie number one and movie number two. Along with movie number one and movie number two, he has watched movie number three, four, five, extra three movies. Okay. So now, if you are watching the same set of movies that user number one is watching, that means you are both are in the same group. Your your both interest lies in romantic genre. Okay. So now, what is the harm if the machine is recommending, say that somebody's watched movie number three, four, five. Okay. Give me 1 second. Okay, I'm getting a call. I'll just answer the call and come back to you. 1 second. 1 second. Yes, hello. Can you hear me, Siddharth and
Yes. Yes,
Kirtana?
sir.
Yes.
Yes.
So what was I saying? So this movie recommendation. So if user number one is watching movie number three, four, and five, the user number two, which is you, can also watch movie number three, four, and five because his interest and your interest are same. Okay. So if they push you those movies, okay, you might see or you definitely are going to watch those movies because the interest is same. Okay, that is why they are pushing all those movies to you. They have to recommend something. Ultimately, they are trying to sell you their products, right? Their services. Okay, so obviously they are interested in making money. That is why they have to do all these things. Okay, so that is movie recommendation, and behind this there is AI. Okay, so AI exactly understands your interest and the other user's interest. Now it goes and compares if your interest matches with plethora of users information or interest, okay, in the backend system. Okay, like you, there might be hundreds and hundreds of customers. Okay, so if you fall into that particular group, and whatever like movies have been recommended in that particular group, the same movies will be recommended to you as well. Okay, so like you, let's say like your friend also has watched the same set of movies that you have watched. Now he is also going to get the same recommendation because you, your friend, and the other users all are in the same group. Okay, so this is how recommendations happen. And we talked about, like we spoke about the email spam detection. So when a particular email arrives, the machine will understand the content of that particular email. So based on the content, okay, so this, it, the machine has already learned about all this content. Okay, so when somebody says that congratulations, you have won uh, 1 million worth money in a lottery or something, so it is usually a spam email that the machine has learned. So when the machine has learned about these kind of emails, and if an email arrives at your Gmail with similar content, okay, it can classify that this mail has to go to spam. Okay, and you will be saved. So you don't really touch all the emails in spam folder, right? Because they are fishy emails. Okay, so you don't really go and view all these emails. Okay, that is what you will do. Okay, so it is protecting you from some kind of fraudulent activity. Okay, so that is what it does. Behind the scene, AI is there. Okay, so these are some real life examples. Now today we will understand what is data. So in the machine like learning life cycle, okay. So you, what is machine learning ultimately doing, right? So it is making the machine intelligent because it is, and the machine is undergoing some kind of learning. So when it is undergoing some kind of learning, okay, it is becoming intelligent. So when it is becoming intelligent, it can perform some tasks. Okay, and in doing all these things, it is following a series of steps, and everything starts with data, information. Okay, so data is just information. It is anything that we observe, collect, or record about real world around us. Okay, so it could be your name. If you say Siddharth, if you say Kirtana, Kirtana is one set of information, one set of data. Now Siddharth's age 15, Kirtana's age 14. Okay, it's also data. Your marks in the examinations, that's also data. Okay, so data is nothing but a raw information that we collect before making any decision. Okay, so in the students example, we are collecting the marks of all the students. Okay, we are processing it. We are making the machine learn about these informations, marks of different students, and then like we are predicting something. That means whatever data set you have, like you train the machine on certain students' data, and right now you have the present set of students data, and you want to predict whether these students will pass or fail in the examination before they go and write the examination. Okay, so let's say like that is the task. So you can make use of this system which has learned something, and you can predict all these students result before actually they go and write the examination and the results are out. Okay, so why you are doing this? So let's say like the uh, school is expecting 100% result, like always with respect to like board examinations. Okay, board examinations are generally taken up by students of class 10 and class 12, correct? Or you say like PUC or whatever. So every school want 100% results. Okay. So when somebody goes and writes board examination, so 100% result is what generally the schools expect. Now, let's say like there are few students in this 10 standard who are bit average. Okay. So what could happen with this particular students? Like they may perform, they may underperform in the board examinations, and they may fail in the examinations. Okay. So you don't know the reality. Okay. So student who is performing well in the class tests or in like examinations that is happening within the school structure, they may be like underperforming in the examination because of different things, right? So they might have some fear when they go and write the examination, confidence problem, etc., etc. Okay, so ultimately they may like struggle there, and that will impact their overall results. Okay, so like before all these things happen, the schools want to understand for all the students who are going to pass the examination, and if there are students, okay, which the machine says that these are the students who will not pass the examination, or even let's say like along with the pass or fail status, you also get some kind of prediction on what is the percentage of marks that they are going to score in the examination. That is also pretty important. Okay, so usually like schools expect a lot of students to get distinction, right? So that means like over 90 percentage. Okay, whatever it is. So that is the main target of these schools. Okay, they want 100% results. They want majority of their students to score distinction, etc., etc. Now this prediction that they have made, like that gives them some kind of idea, some kind of insight, some kind of information upfront. Okay, so based on all these ideas, information that they get upfront, like they can make some decision. If the machine is telling like let out of 30 students in the class, two or three are going to fail, then you go and work with these two or three students. You focus more on these two or three students and improve their learning. Okay, so when you do or when you work with these students and their learning is better, okay, they will go and perform in the examination. Let's say like their confidence is pretty low, okay, they are carrying fear. That should not typically happen. Okay, so you should go and write your examinations with confidence. Okay, for that preparation really matters. Now you are preparing all these students who will or who are likely to fail the examinations because of all these reasons. Now you go and work with these students, you rectify all these issues, and you bring them to a stage where they can confidently go and write your examination. So when they go and write the examination, they will definitely pass the examination, and ultimately you have the or like objective fulfilled where you have 100% success result. Okay, so that is what the schools are expecting. So data is something which you use to do all these, which you can use to do all these kind of things. And when you do all these kind of things, like you get some insights based on the insights, information. Okay, so prediction is some kind of information. Prediction is some kind of insights. So that means it tells you these are the students who are going to pass the examination, and this is what they are going to score in the examinations, and these are the students who are going to fail in the examination, and this is what they are going to score in the examination. That is what you are telling, correct? So that is some kind of information upfront, insights upfront. On these informations, okay, based on all these informations, they can go and do something. Okay, they can make a decision. That is what all these things helps. Okay, so this is applicable across different industries. Okay, it is just not education, even in healthcare. Okay, healthcare is all patient. Okay, so you're taking care of patients. So there, like it depends on like patients. Okay, who are going to like go and get operated. So before like you treat them, so you may understand, okay, if they need surgery or not. Okay, if they are going to like post surgery, how they are going to like recover. All these things can be predicted ahead of time. Okay, whether they are going to get readmitted after like getting the procedure done. So all these things can be predicted ahead of time. So this has machine learning has a role in every industry. Okay, education, healthcare, oil and gas, automobile, finance, okay, sales, marketing, etc. Okay, so this is your data. Example, fruits data. So fruit, in a sense, fruit has got different attributes, and each of the attribute is again data. So when you say apple, apple has a color, okay, red color. Taste, it's sweet. When you talk about lemon, it's yellow in color. It is sour in taste. Okay, all these are information. Now you can use this information, you can make the machine learn about this. And in future, okay, if you have something similar to this, the machine will be able to tell you what is the fruit. Okay, so why data is important? Computers cannot think like humans, so they use data to learn and make decisions. Okay, so they cannot think. Okay, so if somebody shows as a fruit, right, so we don't have to do the processing, right away we'll be able to tell what fruit it is. Now the machines cannot do this. They cannot think, right? So they don't have brain like us. Now you need to build or create this brain. Okay, that is what is your model. So you create this model, okay, and this model has learned something. Based on whatever the model has learned, it can make decisions, it can do the predictions. Okay, that is why data is important. Data is the foundation, data is the base, okay, for everything. Okay, so you should focus more on data and its processing. Okay, so that is pretty important. Now let's understand. Okay, do you think height is data? Now, do you think your favorite game, let's say like firefighter or like PUBG or whatever it is, do you think they are data? They have some
Yes,
value?
sir.
Okay, yes. So they are data. Height, for example. Okay, so somebody is, let's say, like 5 feet 5 inches height. Somebody is 5 feet 6 inches height. Somebody is 5 feet. Okay, all these are data. This can be used, and machines can be fed all these data, and the machine can learn from this data. Okay, so without data, AI cannot learn anything. Okay, if somebody has to learn, even humans, correct, so we need some information, only then we are going to learn, correct? So without any information, we are not going to learn. Okay, for example, when you were a kid, right, so your mom told that I am your mom, your father told that I'm your dad, or your mother told that this is your dad, or this is your aunt, this is your grandfather, this is your grandmother. You needed some kind of information, right? So they taught you something. Only then you can, you are able to make out that that was your mom. So if nobody taught you, okay, who is your mom, who is your dad, then you will not be able to make out that who is your mom or who is your dad. Okay, so here also AI cannot learn anything without data. Okay, somebody should come and push some information. Okay, so based on the information that you push to this particular system, okay, it learns. So this sets up your next topic perfectly. Yes, machine learning. Now features versus labels. Okay, so I think we will understand all these things with some data set. Okay. Okay. Can you see this Excel file?
Yes.
Okay. So have you both worked on Excel files or like any kind of
Yeah.
what
Yeah.
is documentations?
Yeah.
Yeah.
Okay. So you're comfortable working with this, correct?
Yes.
Okay. No worries. Okay. So do you have any idea on features and labels? What do you think features are? Okay. So let's say like you are Siddharth, correct? And you are Kirtana. Okay. So there are two different personalities here. So each and every personality in this meeting has or have their own features or characteristics. Okay. So what do you think is your characteristics? Okay. So we'll go with Siddharth first.
Sir, I'm a boy. I'm 6 feet tall. Are these relevant, sir? Am I saying it correctly?
Yes. Go ahead. Go ahead.
Sir, I play chess. Uh, I like mathematics. Uh, I
Okay.
like to watch movies and read books.
Okay. Okay. So all these are your features, characteristics. Now, Kirtana, like, how do you define about your characteristics?
Yes. Uh, I'm a girl, and I'm 4'11", and uh, I like to read books. I like science, and
Okay.
then I play bad.
Okay. Fine. Fine.
Yeah.
Fine. Okay. So Siddharth and Kirtana. Okay. So you're almost correct. Okay. But there is some differentiation. There is some kind of uh, uh, that there is something that like you need to understand with respect to your features. Okay. So when you say features, correct? You told me that you're a boy, and Kirtana told me that she is a girl. Okay. Boy and girl are not features, they're actually label. Okay. So that is what is defining you, correct? So if you are 5 feet high, I mean in height, age is let's say like 15 years, and weight is let's say like 35 kgs or 40 kgs. Okay. So if these are the characteristics that are met, okay, then you go and tag. Okay, I can go and tag you as a boy. Okay, let's say like now coming to Kirtana. Okay, so if she is let's say like 4 feet 5 inch tall, and her weight is let's say like 34 kgs or 33 kgs. Okay, and to add to this, there are few more characteristics. Okay, now let's say like Siddharth is a boy. So when he is a boy, okay, and when he is a 15 years old boy, so he may have mustache, okay, but Kirtana does not have any mustache because she is a girl. That is also a feature, right? So based on all these features, okay, you can say who the person is, okay, whether the person is boy or girl. Okay, so if you look into uh, this particular example that you have, okay, here you have fruit. Okay, there are different fruits like boy and girl. Here you have fruits. So every fruit has different features. Now based on these features only, okay, you can give this label. Okay, so when somebody says the fruit is red, its taste is sweet, and size is medium, okay, most likely this is going to be apple. Okay, that's what you will say, correct? And you're giving a label saying that this is apple. And when somebody says the color of the fruit is yellow, it's sweet, and its size is long, usually it is banana. Okay, maybe like some other fruit may have this set of features. Okay, to go along with these features, maybe like you can add few more features. But I'm just throwing something, like if the features of uh, this particular fruit is yellow, color is yellow, taste is sweet, and size is long. Usually, this will you will label this as banana. Okay, same way, lemon. Lemon has features like yellow, sour, small. Okay, orange has color orange, taste sweet, round. Okay, now when you see this, these are the features based on which the fruit is actually classified. Okay, without these features, okay, you cannot classify the fruit. Okay, so the machine, when it learns, right, so it needs features and label. Okay, so that means when I give these features, it will go and see the first row of data. Okay, it will see the color. Okay, when the color is red, and when the taste is sweet, and the size is medium. Okay, so you have given this as apple. Okay, that means it will also see the fruit name. When the color is sweet, sorry, when the color is red, taste is sweet, size is medium, the tag is apple. Okay, the classification of the fruit is apple. That's what it will understand. Same way, if the color is yellow, taste is sweet, size is long, then the fruit is banana. Okay, so you are giving this information plus this information to the model. You'll have to provide both the information. Okay, so this is the, sorry. So if I have to tell features, okay, the features are color, taste, and size. And the label is, what do you say, fruit. Okay, so are you getting my point?
Yes, sir.
Yes.
Okay, so this is what the machine has to learn. Okay, so when this is the combination, right? Red, sweet, and medium, the fruit is apple. When the combination is yellow, sweet, and long, this is what is the fruit. Okay, this is what the machine understands. So here you're not writing any instruction saying that if, okay, you're not saying if, for example, condition, if color is equal to red, color is equal to red, comma, taste, one second. Okay, so you're not saying if, okay, so you're not writing any condition like this. Okay, so here I'm writing an instruction, right? So instead of writing instructions, what I'm doing is I am giving these as the input to the model. Okay, it can figure out. Okay, so this is another example. So here marks is feature, pass or fail is the label. Okay, so I'm not writing any instruction in machine learning. Okay, I'm just passing marks and the pass or fail status as the input to the model. Same way here in this case, I'm passing these things as features and this as the label to the model, and the model figures out the the tag or the label, okay, the fruit name. Okay, so that is what I mean by features and labels. So once you have data, so you should inspect your data, you should clean the data, and you should do the feature selection and label selection. Okay, so you'll have to say these are the features, you'll have to say these are the labels, okay, and then pass to the model. The model learns. Okay, so now after this, there is this model, okay, which is like the brain of the computer. This is what the processing happens. This is where the learning will happen. So you have data, you have the features now, you have the label now, you have this model where you input this data and the model learns. Okay, so once the model learns, it can give you the right prediction. Okay, so this is what your model is. Okay, hope I'm clear. Okay, I'm not going in detail, I'm not going to tell you like different models, that this. Okay, so you should have some generic idea how all these things work, right? So when you say machine learning, how machine learns, it learns from data, and this data, this learning happens within a model. The model is the brain of the like computer or the system that you're trying to build. Okay, so this is the processing that is happening within the model. So now you should understand what is good data and bad data. Okay, so I told you, if you have some raw information, the raw information must be of inconsistencies. Okay, so the data is raw, and when the data is raw, there are chances that it has inconsistencies. That means duplicate values, uh, missing values, or even outliers. Okay, so all these things are not good for the model. The model will learn all those inconsistencies as well. Okay, so you'll have to take care of those inconsistencies. Okay, how you are going to handle those inconsistencies, that is up to you. There are methods, right? So either you remove them, you drop those duplicate entries. Okay, so duplicate entries definitely you have to drop. Now, how do you handle the missing values? You either remove that particular row of data where the data is missing, or you try to impute. Okay, so how do you fill that particular value? Okay, there are different methods. So that is what your good data and bad data is. Okay, bad data is something, okay, that is not clean, and if you use bad data, the machine is going to give you wrong predictions. Okay, instead of saying the picture is of a female, it will say male. Okay, because it has like interpreted the data incorrectly. That interpretation came because of inconsistency in the data. Okay, so that should not happen. Your data should be always clean. When the data is clean, you will see better results. Okay, so you will see wrong results when the data is incorrect, and you will see wrong predictions. So if you train with wrong fruit tables, you will definitely get wrong predictions. Okay, so what I mean, when you say, let's say like this is the red, sweet, and medium. Okay, so these are the features. Now if I'm saying this is Goa or something, okay, uh, if I say Goa, okay, do you think this is correct? So Goa is not red in color, it's not, maybe it is sweet in taste, maybe it is medium in size, but it is not red in color. Okay, so you're saying this is Goa, then definitely this is wrong, correct? So this is something which the model should not learn. Okay, it should learn that if the combination is red, taste is sweet, and size is medium, the fruit is apple. So this is something that is not correct. So you'll have to replace this with apple, which is the right entry. Okay, so this is what is called as good data and bad data. Okay, so if this is with Goa, then this is bad data. Okay, so if you say this is apple, this is really perfect data. Okay, so there is nothing wrong here. Maybe some of the features are missing, Okay, but that is fine. So with these features, you are able to tell if the fruit is apple, banana, lemon, or orange. Okay, that is fine. So this is how data should be. Now bias in data. Okay, so bias in the sense, like there is some kind of inequality. Okay, so in male or female classification, so let's say male or female classification, male female. So let's say like you have number of features. Okay, so I'm not sure about the different features. Okay, with respect to male and female. Okay, so you have, let's say, feature one, feature two, feature three. Okay, so this says there is some entry. Okay, let's say you have so many entries. Okay, so out of this, let's say like the first is male, this female, male, male, female, female. Okay, so if you see this particular data set, you have feature number one, feature number two, feature number three with respect to male and female. Okay, so male features might be eye color, that, this, whatever. Okay, hair, nose, all these things. So with respect to all these features, only then you can make out whether that particular person is a male or female. Okay. So now let's say like this is the data set that you have. Okay. So in this data set, if you see the number of how many entries you have. Okay, you have 19 entries. Okay. So let me say 20 entries. So if you check the number of males, 1 second. So if you check the number of males, there are 13 males. Okay, and females are just 7. Okay, so when this is the distribution, okay, and you train a machine on this, okay, it is, the machine will learn more about the males. Okay, or let me say like I will add more males. Now if you see, the number of females are just 5, rest 15 are males. Okay, that means there is a male domination. Okay, the equality is not there. So when you train the same, okay, and make the model learn the same thing, okay, so it will generally say the prediction as male because it is trying to learn male more accurately than the females. Okay, so 15 records or 15 information of different no, like 15% like 20% out of this particular data set are males. Okay, and 55 people out of this data set are females. male dominancy is there. Okay, so when male dominancy is there, the machine will check each and every feature, and it will try to understand that the like what it will infer is, if you have this kind of distribution, mostly it will say that it will understand, it will memorize. Okay, so it will memorize that even if your features are this x, x, and x, okay, the prediction is male. Okay, it may not understand the female characteristics because there is male dominance. Okay, so it will go and inspect the features. Okay, and it sees male. Second, it goes and inspect this particular row, it says male. Okay, so everywhere it is seeing male, 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 male. Okay, so females are very fields are, female are pretty less. That means the patterns of females are pretty less here. Okay, so that pattern it cannot understand. Okay, it understands this male pattern much more efficiently than the female pattern. Okay, so when in future if you are going to give any particular image, it is always going to tell you that the image is of male. Okay, so that means there is a bias here, there is inequality here. That should not be there in your data set. Okay, data set, whatever you have, if you have 20 rows of data, okay, then 15 rows might be, sorry, 10 rows should be of male. Okay, so this should be of male, 10 rows should be of female. Okay, now there is an equal distribution, or it can be more or less. Okay, so you can have 9 or 11, that is also fine. Okay, so males are, there are 9 males and there are 11 females. Okay, this distribution is also okay, but the distribution should be more or less equal. Only then it is going to understand both male and female equally. Okay, the patterns present in this particular data set. Okay, there is one set of pattern for males, there is one set of pattern for females. Okay, so when this is distributed equally, okay, only then it is going to understand male and female equally. Otherwise, it it sees the dominance. Okay, if there is a male domination, if there is female domination, then always it will stick on to that. Okay, and your prediction will always be male or female. Okay, that should not happen. You should make sure that male and female distribution is the same. Okay, that means here if you have 20 rows of data, 10 rows of data must be male and 10 rows of data must be of females. Okay, so only then it is going to learn. Okay, so this is what is your bias. There should not be bias in your data. Okay, make sure that this is not there. Okay, so this is also part of bad data. Okay, so you cannot say exactly bad. Okay, you cannot use that word bad, but some kind of inconsistency. Okay, that is what you can say. Okay, so there should not be any bias in the information that you have, data that you have. Okay, so prediction and decision, which you may know. Okay, so prediction is something that is like you get after the model learns something, and it can like say that based on whatever it has learning. Okay, so here in this case, okay, so in this example, now the machine has learned about all the fruits like apple, banana, lemon, and orange. So tomorrow, let's say like I have fruits like this. Okay, so I don't know. Okay, I don't know what fruit it is. Okay, so I have similar pattern. Now let's say like I have something like this. Okay, the size is medium. Okay, so I don't know what fruit is this. So this information is what I need to input to the model, and the model has to tell me what is this particular fruit. Okay, so now it has learned a pattern saying that when the fruit is yellow, sweet is sorry, the taste is sweet, and what do you say, like the size is long. Okay, it's a banana. When this color is yellow, taste is sour, size is small, it's a lemon. Okay, it is seeing a similar pattern here. Yellow, sour, and small. Okay, so it is lemon. That is what it has learned. It will say lemon. Okay, now you see this particular row of information where you see the color is yellow, the taste is sour, and the size is medium. Okay, now it has not learned about this pattern. Okay, even though it has not learned about this pattern, okay, it is going to guess, it is going to say lemon. Okay, based on the other similarities, the color is yellow, the taste is sour. Okay, the only difference is the size. Okay, so this also should exist in your what do you say, like your data. Okay, it should have something like this as well. Okay, only then it is going to be sure, 100% confidence will be there. Okay, so if you say medium, the size is small or medium, and the color is yellow, the taste is sour. Okay, the fruit is lemon. If this was there with 100% confidence, it will say lemon. Okay, now the confidence of saying lemon is maybe like 80%. Okay, if this was there in the training data, okay, so it would say with 100% confidence that this particular fruit is lemon. Okay, so prediction is something, okay, which in which you're telling what the actual fruit is. Now, based on this particular insight that you give, based on these predictions that you give, okay, somebody can make a decision. Okay, so let's say like you have a data set and it needs to be classified. Okay, and this particular data set has characteristics of lemon, banana, apple, orange, everything. Okay, so you make out that after prediction, majority of the fruit is orange. Okay, now you have the count. Okay, and very few let's say very few bananas, very few lemons, and very few apples. Okay, so based on this, you can take some decision. Okay, let's say like the farmers are doing this thing. Now they have to get the count of whatever is there with them. Okay, so if lemon is on the higher side or apple is on the higher side, then they make a decision on that. Okay, so now let's say like uh, the count of apple. Okay, let's say like they have 100 different fruits for classification. Out of this, let's say like there is you make the prediction, and you say like there are 70 apples within that particular distribution. Now they can make a decision saying that since we have a lot more apples, okay, we will go and sell this in the market. Okay, so that is what decision is all about. Okay, the farmers, they make a decision saying that when I have 70 apples, then why not I go and sell this in the market? Okay, I will make some money. The rest of the fruits are, like in lesser quantity, 10 what do you say, lemon, 10 banana, 10 orange. Okay, so this may not be like useful for me. Okay, I may not be able to make some money. Okay, and that particular money will not be enough for my like let's say like for today's expenses. So if that is the case, then they will sell the number of sorry, they will sell the fruit that is higher in number. Okay, so now all these fruits, whatever they have, okay, so let's say like they are growing this in their farm. Okay, they are plucking it from the plant after it has like ripen or something, and they have to they have the device or something which does this classification for you. They don't have to count it, they don't have to put it into a basket separately, like they don't have to do a manual job. Okay, the machine will do the counting and it will segregate different things. Okay, so if that is the case, like this is really helpful. Okay, so this is where machine learning comes into picture. It does the prediction, it does the counting, it does different things based on which they can make some decision. Okay, so this is some example. Okay, so I have something built for you. Okay, so I have an application. Okay, this for this you need to code. Okay, So I will uh, go to the coding part. Okay, maybe in the week 3, or I don't know, like in the second week, I don't know. I will be touching the coding part in the second or third week. Okay, so now let's just have a uh, look at one of the example. Okay, which does this classification. Okay, so this is an application. So what this application does is it tries to classify your fruit. Okay, so whatever fruit image you give, it identifies the characteristics of that fruit, and based on the characteristics, okay, it is going to tell you what fruit exactly that is. Okay, so that is what the application is all about. Okay, so here if you see, the application has learned about the fruits. The model has learned about the characteristics of the fruits. Based on the characteristics of fruits, okay, it can make prediction. Okay, now I have few images to test. Okay, I will give few images. Okay, so you see the result. I have the images of like different fruits like apple, banana, lemon, and orange. Let me test one by one. Okay, so let me take orange. So I am uploading the fruit. Okay, so it is showing the image. Whatever image you uploaded, it is showing the image, and it does the classification. Okay, it says this fruit is likely to be orange. Okay, and the confidence is 71%. It can be Granny Smith. I don't know like what Granny Smith is. Okay, the likely chance of this fruit being Granny Smith is 1.41 percentage. The percentage of this being lemon is 1.07 percentage. Okay, so why it is giving you this confidence? Okay, so based on confidence only, like you can believe this, correct? So since it is saying 71% orange, okay, this can be orange. Okay, so you will be sure of that. Okay, let's test with a different fruit. Now let's say like I'm going to upload the image of banana. Okay, I'm uploading the photograph of banana, and see the predictions. It is saying 97% this is banana. Okay, I don't know like what slug and hook is. The final prediction is banana. Okay, so that means it has learned about banana really well. Okay, so even if you upload a different image of banana, maybe like what do you say, like raw banana, okay, it is going to make out. Okay, so you're told that the color of banana is yellow. Okay, so to certain extent it might identify raw banana, but I'm not sure. Okay, so let's test that also. Okay, so I will do that as well. Okay, so let me give this image. Okay, so now I will upload the raw banana image. Now let's see like what it is classifying this as. Okay, so it is still saying banana. Okay, maybe like because of the size. Okay, and color definitely it will not be able to make out because this is green in color. The color of banana that it understands is yellow. Okay, it says bell pepper. Okay, I don't know like how this is similar to bell pepper. Okay, so ultimately it is saying the final prediction is banana. Okay, 20%, that is on the major side, right? So that is why it's saying 20% banana. Okay. So anyways, so this model, whatever you're using, okay, it is learned well, it has done the learning pretty well, and it is giving you right results. Okay. I will test lemon and apple as well. Okay. Yes. So this is lemon. Yes, it does the classification. It is saying lemon. Lemon 98%. Okay. The confidence is 98%. That is really good. That means it has learned about lemon pretty well. Apple. Okay. No, apple it is saying orange. I don't know like how this looks like a pomegranate to this. Okay. Maybe there is some similarity of this with pomegranate, but I don't know like why it is saying orange. Let's upload a different picture of apple and see. Okay. So I will use this. Okay, let me go here. I will upload this image. Okay, so image is uploaded. Not a known fruit. Okay, it's not able to identify apple. Okay, so that means it has not learned about apple at all. Okay, so the other image of apple also it was not able to identify. So now it's saying not a fruit at all. Okay, I don't know like how this looks uh, to the model. Okay, so anyways, so majority of the thing it is able to classify, correct? So banana, lemon, orange, it's all it is able to classify. Apple it is not able to classify, but that is okay. So this model, okay, it's an already what to say like already existing model. I did not build the model. Okay, I did not train the model. So this model is from Google. So this model from Google is really working well. I'm not sure about. I did not test on different fruits. So this model can be used on any images. Okay, even if you have different images of phone or different electronic items, and you want to classify those items, you test with this particular model. Okay, so it's called mobile. One second. Okay, it's called as mobile net V2. Okay, so mobile net V2 is from Google. Okay, so it's been trained on different images and it can classify any images. Okay, so anyways, so you don't have to worry about how to create all these things right now. We will go there step by step. Okay, hope you are getting the complete picture. Is it not like how things are
Yeah.
built? Okay, so if you have to build something like this, now this application, right? So you can build this for a farmer. I told you, right? So farmers are reaping their fruits. Okay, so they have a farm. So every day they are collecting different fruits from their farm. Now, if you have this application and there is a camera, okay, there is a device which has a camera. It takes the like input through the camera. Okay, here I am uploading. So instead of saying browse files and taking the input from me, okay, the device takes the input. Okay, it can capture the images of each of the fruit. Okay, and does the classification. It is going to really help the farmers, right? So they will understand ultimately out of 100 fruits that they have plugged out from the farm, how many are apples, how many are banana. Okay, they will get to know that within like few seconds. Otherwise, they will have to count manually, right? So that counting process is really difficult. If there are, let's say, like 1,000 fruits, okay, so this will consume a lot of time. Manual labor is there, okay. So all this can be eliminated with like bringing technology here, okay. So that technology is this, okay. You are building an application which does what a human does, correct? So we are doing it manually, okay. We are taking each and every fruit, we are counting, we are putting them in a like separate baskets, so that need not be done. So even like counting and putting those fruits into different baskets can be done by machine, okay. So you can also have a device which can pluck, which can understand what is the fruit, it can predict what is the fruit, it can classify what is the fruit, and it can take that particular fruit and put it into different baskets. That also can be done. So that will save the complete it will like save total 100% of like the farmer's time, okay. So if the farmer is taking for this process, let's say like 1 hour, okay, 1 hour to count 500 fruits or like 1,000 fruits, so this can be done within like 5 minutes by the machine, okay. So even not 5 minutes, okay. So I don't know how much time it will take, but things will be more faster, okay. Think about the count of the fruits. If the fruits are like typically of the order of like 10,000 1 lakhs, okay, then you just think about this, okay. And also the if the fruit is the same, let's say like you are trying to pluck banana, okay. So banana can be sometimes ripened, okay. So sometimes it can be raw. So you make the differentiation which is ripened, which is like raw, and you put it into different containers or baskets, okay, and then you go and sell them. So typically when they like harvest bananas, okay, typically it will be in the order of thousands, lakhs, okay. So that is how things are complex in the real scenario. And if this has to be like that complexity has to be eliminated, then we are trying to bring in technology. This is how technology can help, okay. And how we are building this technology, there is some kind of process, okay. That process exactly I've told you, okay. And we have seen one particular example, okay. Hope I am clear. And if you have any doubts, please do get it clarified. I'm not going to go to the coding part. Okay, so I have coded this. Like I have written instructions. I have written a program which does this. Okay, so in the sense, like I've written a program in the sense, like I'm not what do you say? Like I'm not writing instructions in the sense I'm not feeding each and every sample saying that if this particular fruit is like having a color of red, then size is long or taste is sweet or sour, the fruit is apple. I'm not saying that way. Okay. So even then I have to code this. Okay. So that is what I have done here. So this you don't have to worry. This we will do stage by stage. Okay. So even if you can use this and run this application and get the results, that will be fine. Okay. So I will see like how to go about this. I don't have any plans as of now. Uh, Anyways, so I think this 1 month duration is not sufficient, but we will try to use most of our time and let's see like how to go about building this. Okay. So if we have to code like this, like it will take some time. Okay. So maybe something very simple you can do. Okay, maybe you can build something like a calculator app or something. Okay, get started with coding or something. We will do that. Okay, so this is one application that I told you. Okay, so this really is useful in the industry. Okay, for the farmers, agriculture, whoever is doing agriculture, it is really good. Okay, so any doubts, Siddharth and Kirtana? I think I am done for today's session. If
No,
you
sir.
have any doubts, anything to ask, you just let me know.
No, sir. No, no.
Okay. So do you have any kind of hands-on on coding? Like Siddharth, you just told me that like you are having this in your like curriculum,
So we
correct?
have Python in our curriculum.
Yes. Are you doing Python coding and all?
Yes, sir. Like in our syllabus it is there, but I'm finding it really hard.
Okay, okay, okay. So as a separate subject, do you have Python or like how is
No,
it?
it's like it's a part of AI. It does come under AI, but it's uh uh, like in our exams, like they have a section for artificial intelligence and for Python coding program.
Okay, is it a practical kind of subject or like fully theoretical?
So it is not fully theoretical, like the coding, like how you just showed us now, it will be like that.
Okay, so that means like you go to your computer labs
Yeah,
and
yeah,
maybe like
yeah,
you do the coding part. Okay,
yeah,
okay, so that means like you can code, right? So maybe like
yeah.
you're finding difficult, but at least you just started coding, correct?
Yes, sir.
Okay, since how long you have been coding? Like, uh,
Coding means from last year, sir. Like,
okay, yes. So since last year you are having this in your curriculum, is it not?
yes, sir.
Okay. So is this a continuation? Like right now you're in 10th standard, correct? So is
It,
this a
tenth is a
continuation?
continuation of last year, sir.
11th also you have this? 11th, 12th?
I am not sure, sir.
Okay, okay. No worries. Okay. So this will take some like time to mature, correct? So you cannot learn this in just 2 years or something because like you're going to school and you are having you need to concentrate on other subjects as well, right? You cannot do this full time, correct? So since that is the case, okay, in school setup you'll not be able to learn this fully, and even school teachers, right? So I don't know like how well they are educated in this particular area and how well they know about this particular topic. I'm not sure. Okay, so this is a good opportunity, right? So
Yeah.
you learn here and you will really get to build some applications. Okay, maybe like simple applications. I'm not talking about an application that I showed you. Okay, something at a basic level that should be very good. Okay, so make use of this session and please focus. Okay, that is what I would tell you. Please review the recordings and the notes, etc. Okay, and please do ask me questions. Okay,
Yes, sir.
how about you, Kirtana? Like uh,
They're gonna start coding for us now. We haven't done anything yet.
okay, you don't have it in your curriculum.
No, we have it, but we haven't started it yet.
Okay, okay, right, right. Okay, anyways, so we'll get started. Okay, here in this particular course we will get started. I'm not sure like how to start, where to start, because it needs time. Okay, I'm thinking about the time as well. Okay, so anyways, I'll do my best and I will see like how I can teach you. And like after this course also, like this is a 1 month course, correct? So even after this course, if you want to connect with me and work with me, definitely I'm open. So you do connect with me and we will do this extensively. Okay, so you just let me know after the course. And if any of your friends are also there, okay, so do bring them. Okay, so you just tell about the course that is going on, and if you can share the recordings to them, that is also fine. Okay, I have no objection, you share them. And if they feel good about the course, then definitely if they are willing to join, then they can join. Okay, so maybe like I will take them in a different batch or something. Okay, that I can decide, no worries. So you just check with them as well, right?
Yes.
Okay, so I think we are done with week number 1. Okay, so at least we got some understanding on how everything works. Okay, so in the subsequent week we will start coding and we will build some simple applications. Okay, and maybe like we will see how to use AI in different things. For example, like in your school setup, AI can really help you on few things. Okay, so we will see all those things. I'm mostly sticking on to your school and other stuffs. That means education, and we will build some applications around that. Okay, is it okay?
Yes, sir.
Yeah.
Okay, fine. So if you have no questions, please carry on, and I will send you all the recordings. Please review the recording. Okay, that is my sincere request. Please do that.
Okay.
Okay.
Yes, sir.
Thank you, Siddharth and Kirtana. We will meet on this Tuesday, because we are meeting on Tuesdays, Saturdays, and Sundays. And if you have any commitments on Tuesdays or any days that we meet, correct? So you just let me know in advance. Okay, we will go according to that.
Okay.
Okay, then carry on. We will meet on Tuesday. Bye.
So, thank you, sir.